Let's start. I know you're sneaking out there. Christina, couldn't you please come a little bit closer? Because we're not so many people here. Oh, okay. I want us we had some people that were a little bit too busy to actually come. There were some things coming up. But the ones who are here, you are so very welcome to our third, hello, breakfast seminar at, don't sit too far up, please, come a little bit closer. I won't bite, I promise. So my name is Pia Wagberg and I work for RISE Bioeconomy. And I'm the facilitator of these breakfast seminars. And Helena, who's up there, Helena Halonen, she is actually the one doing a lot of the work for this. You know her name if you have registered. We try to have these seminars 4 times a year with a certain certain theme. And we try to make it very short, effective. We have one presentation from us here and one presentation from an invited speaker that we collaborate with. That's the idea. And then hopefully you come up with some questions around these issues, and hopefully you will get a follow-up mail afterwards. So hopefully if you have any questions around this further on, you can contact us, okay? So by that, no more practicalities. We will have Ignacio, and I'm always very cautious when I say your last name because it's not my, Ignacio de San Pio. Yes, right. So he's not Swedish, obviously. He comes from Spain, but we've had the pleasure of having him as our associate here in Stockholm for 3 years. But he's been working several years for the Spanish paper industry. Hello. Where you worked a lot with water as a key issue. So a lot of experience from Spain, where actually water is a scarce resource. So water treatment is a very important topic there. So we'll start with that, and we'll take our guest afterwards. And the title of yours, I like your title here, saying saving money while saving water in the pulp and paper making. Yes, I'm really anxious to hear what you have to say, Ignacio. So please.
Thank you very much, Pia. I think there is also people via Skype, so I have to speak here. I hope they hear me.
While Ignacio is doing that, I just want you to be aware that we have about 10 people on the webinar as well. So, yes. Yeah.
Okay, so thank you, Pia, for the introduction. Thank you all for being here. And I have a very nice and very interesting pleasure here to be in Sweden and to try to speak about water in one of the most water abundant countries. So it's a challenge, and it's very interesting when we consider the importance that water can have in paper industry. Wanted to give some background initially. So first of all, water is important worldwide, and it's getting more and more important. And it's, if we think now on the World Economic Forum data, is placed, the water crisis is placed as one of the most probable risks and the most dangerous risk that we are facing today. And therefore, it should be a concern not only for the poor countries, not only for the water scarce countries, it should be something that we all have in mind. But there is a crisis. Why? Why there could be a crisis on something that is so abundant and additionally it's cheap? Is it maybe that it's cheap, it is abundant, and we haven't put enough effort into that? But let's start, and for you so interested in water, there has been now a report written quite recently from the European Union about the research strategies for the next years. And I liked one sentence where they said that we have to do something also in the countries where the technologies are there, where the water is there, in the sense of show that this is possible and that we do the development here. So when I thought, and a bit with my Spanish mind, about how is the situation in Sweden, where pulp and paper making is so important. And I saw that Sweden has quite a special case because 61% of all the surface water use is used for industry. Only 23% for household, very little for agriculture. And if we compare this with other areas in the world, we will see that, by the way, Sweden is the area where there is the biggest usage of water for industry. More than Northern America, more than Europe, and if we compare with other countries, then it will be where agriculture is a lot more important. But that also means that it will not be the population, it will not be the agriculture that should drive the question here in Sweden. It's the industry that has to do something. And as you probably know, water is not everywhere. So when we speak at country level, that doesn't mean that all the country has the same amount of water. So there are dry areas in Sweden, and there could be some local things, even in such a rich country, let's say in Sweden. How is used this water in the industry in Sweden? And that's a very interesting graph. And I wanted to highlight two things. First of all, that pulp and paper making is the biggest industrial user of water, but it's even the biggest. So pulp and paper industry consumes 27% of all the surface water that is used in Sweden. But there is any other important data when it comes to paper industry is that 60% of this water is directly mixed with the fiber. If we compare with other industries where most of the water can be used for cooling or for indirect contact, in our case, more than half of the water we use is directly, we could say, dirty in the process. And therefore, it will not be an issue to find other sources of water. It's really on how are we using this water. And that's what I will try today, trying to simplify the concept to explain how maybe this can be done and how we together, and when I say we, I speak about the water treatment companies, about the research institutes, the paper mills, we have to work together into that. What has happened if we look at paper industry in Europe? If we look between the years the 90s, there was a huge effort. I explained this graph slightly. So what we see here, yes, I have my arrow. The production of pulp and paper increased extremely, but the water consumption was decreasing. So until 2006, there was a big effort from the paper industry, the pulp and paper industry, to reduce the water consumption. But what has happened since 2006? Big paper crisis, 2005, 2006, the printing paper in big decrease, so the production was not increasing. But it seems that the efforts on saving water were not continuing either. So it was like we press the pause button, and during more than 10 years, there has not been a clear or at least a visible effort in saving water in pulp and paper industry. Why is that? How can we change this? First of all, we have to understand the needs. And when we think about the needs, it's not only the lack of water or the drought. It could be also problems with incoming water quality. We can think also on seasonal variations that can mean that in a given moment, your incoming water is changing a lot. Could be changes in legislation. We were discussing this now during the breakfast, that it can come suddenly a change in legislation and we are not prepared for that. And then it's when the urgency comes and maybe some bad decisions are taken. Could be costs, could be efficiency of the processes, or it could be other related problems like corrosion, the slime, which is well known in paper industry. Could be that the water treatment plants are obsolete, or also the sludge. The sludge is always, that every time we speak about water, we have to think about the sludge, about what will happen with the rest of things. So, but then we go to our customers on the paper and pulp mills, and they don't want to speak so much about water directly. Water is more a problem for the environmental guys. So how can we speak with the production manager? How can we speak with the, let's say, deciding people about water and what they have to do? So first of all, we want to understand what are the costs of water. The first cost is the costs that are directly linked to the water. So we call the water usage and the water usage cost. So that means how much you pay for treating your water, how much you pay for the water you take, how much energy is directly linked to water. So that's our costs that are relatively easy to identify. But what we will see is there are a lot of water-related production costs that have to be identified in order to put all the costs that are really linked with the water management. So we want to change a bit the perspective. So many times we speak about the specific water consumption or the amount of effluent. Now we have to see how is the water used in each of the different units in the process. And that is where we have to understand the cost. So going and defining at the different levels, there is one thing that surprised me a lot, that somehow the concept in Sweden that the water is free. First of all, the surface water is shared with the agriculture, with the cities. So that doesn't mean that there is free water for everyone. That means that every drop of water that the industry is taking from the surface water can be used for something else. Secondly, since it's not, even if we call sometimes fresh water is not so clean, we have to clean it. So already from the beginning, we are adding several costs. Had an interesting data from UK paper industry, where they said that this cost on the freshwater treatment and the effluent treatment can go up to 15 pounds per ton of produced paper, which will not be the bigger cost, but now we're speaking about some figures. But as I said, the water directly related costs, they are easy to identify. Let's try to go to the non-some visible costs. And the first thing I wanted to speak is, let's think about the chemistry, about what happens when we reduce the water consumption. What will happen with I let you choose any kind of contaminant. You will always get an accumulative effect. And that means that we will be normally playing in a given level, but that means that probably there will be a maximum that can be achieved. So we will have one cure for each different contaminant like that. What is driving this cure in pulp and paper making? And what defines the maximum we can achieve? Normally, these cures will depend on the pulp type, on the water quality, but also on all the additives we are adding during the process. And therefore, it can be sector specific, but it could be a bit generalized, and we can find some of these correlations. But that will not be enough to be able to convince. So if I go to a paper mill and I start speaking about COD, maybe I cannot manage to convince them to really get the attention. So let's take now these contamination parameters to the x-axis, and let's try to put process-related problems on the y-axis. We can speak about the consumption of a chemical. We can speak about the risk of precipitation in a refiner. We can speak about the time needed to the water and therefore the productivity. And therefore, we will get a given cure. These are completely, let's say, invented cures. So please don't take this as. But what will be important is how is the shape of this cure? What is the levels? What is determining this cure? Then we are more going to the process itself, to the equipment itself, and is when we need the inputs from the different partners and the different stakeholders in the water industry. And that's where we think that RISE can add some value, on the sense that we know a bit about water. We are not selling technology. We are not selling any kind of treatment itself, but we know about the paper making process and the pulping process. And therefore, we can understand what is the impact of a given degree of contamination in the process itself, and make these links and create these cures. The third cure that's maybe not for us to define, is when we take these problems and we relate it to the cost. That's probably more on the mill side where they can relate this. But some, I would say many times it's quite a linear relationship in the sense of the more problems you have, the higher cost. So the exercise will be simple. If we take the 3 cures we have been speaking about and we put them together, we can define what will be the cost, the production cost related to a given degree of water consumption. And therefore, if we take these 2 levels, we said, so that's where we are normally working and that's the maximum. What will happen if we can, by cleaning the processed waters, realize that we can get to a different cure. And therefore, we can save money for the same water consumption or save water for the same contamination. Or do both. That's the title of the presentation, saving cost at the same time that we are saving water. But I wanted to add one additional parameter that is very important to consider as a cost in a paper mill. It means that when normally a mill is working here, when the machine is clean, as the production process advances, we will reach that level, and that's a moment where we need to stop the machine, we need to do a cleaning, or we need to do something. Because continuing producing will affect the product quality, will affect the cost. By changing to another cure, by decontaminating the circuits, we will also increase the time that it takes to reach this level, and therefore we can be even increasing the production runs. So there will be an additional benefit on this decontamination process. How can we do that? I will go back first of all to the other cure. Because of course now it will be, we can say, mill specific or case specific. It can be a factory that they are here, so with a very high water consumption. And they will feel that they are quite far away from the benefits that you get here. But we have said already, and if we consider that we are in the 21st century, that sustainability is a must. We cannot allow, being paper industry, the maximum in the individual water consumer, we cannot accept to be living here, but we need to show what are the right way to go up to this cure with the minimal impact for the factory. And that's just, I always said, we cannot start building the house from the roof. So there will be some steps we have to do before thinking in decontaminating. So we have to use the right amount of water on the right place. That's what we call the water management, understanding the quality. Then we have to start closing the water loops, which are my opportunities to directly reuse the water. And then it will be time to think about internal treatments. And that's very logic, just because the water treatment cost will increase also exponentially as we go to higher needs. So it's nonsense to install directly internal treatments when we have to treat twice the amount of water. Just a comment, this graph is a real case scenario from Horman paper in Madrid. And that's what we want to suggest as a strategy. And as we said, not only for rice, it's a strategy, it's a mindset for the industry, understand? So taking the water quality management, defining the problem, identifying which are the specific risks in the different operating units, characterizing and understanding it. Secondly, rethink the process, rethink the water loops with the help of simulation tools. How can we evaluate the potential of the different alternatives we have? And finally, testing these curves. But that's something, if we think on this accumulation curve, that's something that can be done at lab scale, at least to identify the potentials. And then is when, and I give the word to my colleague from IBL, when we need the water treatment companies to make this feasible. And I think, and that has been my experience, that if we remember that since 2006, there was very little effort, that's not the case for the water technology. So there has been a lot done on water cleaning during these years. That means that what was, maybe in 2006, it was economically unfeasible. Now it looks quite different. So that's when we really need to show that it's not only that it's possible to clean the water and that cleaning the water leads to some benefits, it's also that cleaning this water is not so expensive as we tend to know. Thank you very much.
Thank you very much, Ignacio. Thank you. Are there any questions? Or yes, then
I think there will be more time for questions also after Stefan's presentation.
Does this work now? Yes, it does. Hello, Ignacio. I wondered when you talk about costs per water consumption, from the company's perspective, they of course have to calculate what it would mean to recirculate and start saving. But there's a political dimension as well, because you must, or you could, calculate alternative costs. And if you're decreasing water consumption, that releases some pressure on the overall consumption in society. So there are societal gains also by decreasing the consumption, of course. But those are benefits partly that comes in other enterprises or in the society as a whole. But if you calculate over the whole board like that.
That's the key, and that will be, I would say, water 2.0 now. We always put a something 0.0 after it. When it's not how I handle the water, is the water as part of the society, if I understand well. So it's not only what I do, it's what the others around me can do. And that will be, I also looked at Tatiana on the sense that that's circularity. That's when we can say that we are using, as a society, we are taking the best. But for the moment, and depending on each country, this is not pushed by the legislation or by the different actors in the sense. So it's really an individual use. The case in Sweden, I think it's only the environmental permit that is regulating how you use the water. And you don't need to renew your environmental permit so often. So I think there are companies that they have the same environmental permit for 20 years. They are not even producing the same product. They have changed a lot, but they are still keeping the same environmental permit. So we need to create this change, but we think that paper industry have to be the first ones to do something because we are the main users of water.
Could you just, a bit late, repeat the question? What was the question?
What did you answer?
What did you answer?
Okay.
Short.
So the question was, if I understood, because I have given probably a general answer, is how can we drive or how can we quantify the societal benefits of handling the water properly? If I understood.
Okay. Any other questions? Might I just add from my own experience that I think your perspective here is very interesting because to me in Sweden water has been ubiquitous. Oh, I'm doing the same mistake. I just wanted to give a comment on water treatment. I think this is so interesting because we're living in Sweden with all the water around us, and we think we're so good and so water is so ubiquitous. It's quite interesting to listen to the hard facts on this, and that we really have to be cautious as one of the very important sustainability goals for us. So this is I would just like to say that this is also something that we have included in our research strategy at Rise Bioeconomy, water as a very important issue to address. So thank you so much, Ignacio. If you wanted to say something or comment on that, it feels like you.
No, it's as Pia said, so it's identified and it's something we have to do now.
Yeah, exactly. So thank you so much, Ignacio. Let's give him another round. And the next speaker today is our partner here from IVL, Staffan Philipsson, and this is IVL. I didn't know that was called the Swedish Environmental Research Institute, but
now you know.
Now I know. And you're the senior project leader and also working with business development, right?
Yes.
So the floor is yours.
Thank you very much. Thank you, Ignacio, for this very nice presentation. And for me, it was also a very good introduction for my presentations, because normally I have to start up and tell why it's important to save water and chemicals. And I used to say that we have already customers that ask us, where could you tell us where to place our next increased production site? Where should we invest for the next 20 years? Because we want water 52 weeks a year, not 50 weeks a year. We want to run the plant all weeks a year. So that's really a discussion of economical development in the future, if you have water or not. And then you have to discuss how to save water as well. And you also went into this discussion about quality and water savings. And that's also what I'm going to discuss in my presentation. So now I have to understand, like this. So I'm going to talk about a way to introduce water savings into the industry, and also chemicals savings. And I'm going to talk about one case study we are running right now at Volvo in Umeå for trucks manufacturing, and how we are running the projects there to overcome those challenges. Very shortly, IVL was founded in 1966, and we are owned by a foundation that is shared between the industry and the government. That the idea is that we should deliver applied research to the society. And nowadays we have 300 people, roughly, a little bit more. And it's not just civil engineers and biologists. Nowadays it's economics, and science and social scientists, etc. So, and we also, I will tell you, also believe in try to make impact at the global scale. So we are working both in Sweden, but we also have local employees in Beijing, Wuhan, and now since January this year, Mumbai. And also we work quite intense with EU projects. I'm a coordinator of one Inspire Water project that also aims to save water in the industry. And we are working in this case with Sandvik. And why do we go abroad? And why do we try to? Because we think actually, to be true, on the global scale, we are a really small country. We are half the population of a biggest city in the world. So our chance to make impact is to try to be in the front and show that it's possible to do developments in the environmental area. And that's also true for water. Even if we have a lot of water, we could make impact by showing how we could reduce the consumption. And if we are successful, there will be a huge market for those technologies and systems. So we should try to be in the front. And we also think we could make impact by going out more broadly. So one idea we had together with Nya Carnegie Brewery and Carlsberg, we made a beer produced by recovered municipal wastewater. And then Nya Carnegie Brewery brewed this beer and sold it at Systembolaget. And it was very, very popular. So it sold out in less than 2 weeks. And we have a lot of prizes. And what we really tried to do was to raise the awareness of water and the importance of water. That was the main goal of this. And we were very successful because we had 470 million viewers of this in just a few months. So now we're going to talk about this way to introduce water and chemicals recovery in the process industry. And that's a combination of introducing water recovery, but also a way to get into the processes and the industry is to not just say that you will save the environment, but we will also try to go from the way that we will improve the product quality in the same time. You also mentioned that, Ignacio, that it's quite a big difference that to go between two levels of impurities from the start, and in the end you have to start up the process again. If you introduce separation technologies, you could continuously move out impurities from the process and have much more stable quality. So today, very often you see abroad, but in Sweden we have started up to go more close to the processes. But in the beginning, when we started at IVL at the 80s to introduce separation technologies, we find out that if you go end of pipe, after you mix all the effluents and try to bring out the impurities, you will have a very complex water, of course. And that means that if you introduce more sensitive separation technologies, you're going to have problems. So what we learned was that we should go as close as possible to each process in the industry and put the separation technologies into the processes. And that's true. And here is one example where we have been working with both Scania and Volvo in different projects. And phosphating is a process where you take the steel plate before you should paint the cabin or the car. You have to clean the steel plate. You have to introduce phosphate layer that is corrosion inhibitor, but also a very good surface for the color, for the paint. So that's what they do in large processes all over the world in car industry and truck industry. And this is a quite complex production or process. You have those degreasing, phosphating, passivation, and it's huge amount of water spent in this, huge amount of chemicals and big volumes. So it's similarity to pulp and paper, even if they use even more water, of course. But you should also be aware that there are many different single process steps into this process, and each of them will co-correlate to each other. What happens in the beginning of the process line will affect the process also in the end of the process line. So therefore you have co-correlation that is quite hard to understand the relation between the process bath chemicals and the product quality. And when we introduce this way of thinking, you very often meet no, we have totally control of our process. We know which pH we should be in between. We know which connectivity we could have in the different process path. We have very good control today, but that's learned by experience, as you say. You have learned where you could be in the process angle, but you have to, if you want to start to recover water and chemicals, you have to have knowledge about your process. That's the hinder why the quality manager or production manager are not very happy to start to recover chemicals and water in the process, because they think that actually this will change your process quite a lot. And then you have the hinder for this. So we have to overcome this. So today, most often introducing water recovery processes, that's quite common in Sweden today and in Europe. you have a separation technology, for example, at the rinse waters, and bring out the impurities. And then you form a waste of the impurities, but that's also containing the process chemicals. So you form a waste of your process chemicals and the impurities. So what do you want to do? Why form a waste of those process chemicals? Why don't go back to the process? And the main resistance lies in that then you're afraid that you will affect the process. You will accumulate impurities in your process path. So to overcome this, we have this resource-efficient quality optimization that contains 6 steps. The first one is to find the real correlations and learn about the process. Find the correlations between the process parameters and the product quality. You have to learn and understand this, not just use those limits that you're running today. And then you should be able to, if you're successful finding those, you should be able to predict the product quality by the process parameters. But you also have to take control of the mass balance of your system. Very often you don't really have a good control. You don't know really how the process flows goes actually. And then when you know by this learning of the process what's really important for the process for the product quality, then you should learn how to take away the impurities from the process path. And then you could start to recover water and chemicals quite with caution. To do it, not just start up this process, do it with caution. And then increase the recovery rate stepwise. So how to find the process, the correlations between the process parameters and the product quality. You use multi-rate analysis. We have a department working on this, and we also seeks cooperation with RISE, because we might be quite good to recover water, etc. But we need also the knowledge, if you should be successful, about the processes, for example, in the pulp and paper industry. We need to sit down and discuss those with the companies but also the experts. What does those graphs mean? What are actually the real impurities in this, what we find out from the multi-rate analysis? And then if we find those correlations, we could predict very nice correlations between the process path parameters and make a data model. And then you could, in real time, find the product quality on the products. So normally this takes 2 or 3 weeks until they have the results about the product quality that was run through the process 3 weeks ahead, before, because they play every second week. They put a steel plate through the line, and then they analyze it, and it takes another week. So 3 weeks later, you know what kind of product quality you had 3 weeks before. But if we introduce these systems that you could predict the product quality, you could have it on real time. And this is also interesting. If you have this, if you're not very successful of predicting the product quality, you can see you have outliers. This means that you don't collect the data that's actually affecting the product quality. And that's also very interesting. You have to start to understand what is actually affecting your product quality. And when you have this, learn this, you could put it in a data model, and you could analyze continuously. And you could also have the product quality continuously showed in a graph. And then you could really have good control over the process. And then you also should have good control over your water and the mass balance of chemicals. This sounds very obvious and simple, but if you go into a process, you will find that maybe someone shifted the water well, so that water doesn't go this way actually today. And you think that you will accumulate a lot of chlorides here, but actually it depends on another thing that you thought. You will learn a lot to go through the process quite in detail and discuss it with the process engineers. And as said, when we know what actually had to be taken out from the process selectively, you could start to do that and learn how to do that by introducing separation technologies and test which one works together. And very often you have to combine some separation technologies to be successful. So then you have the system, you know how to recover water and chemicals, and you have a good process control. So what happens in the process, you will follow in real time. And then you could, also the quality department will say that, yeah, okay, let's have a try. And then you can start to introduce those closed loops. And after a while, you'll see that the product quality is stable. And you could then start to introduce in full scale recovery of water and process chemicals. So by using this strategy, resource efficient quality optimization, you could recover both water and process chemicals. You could maintain or even probably improve the product quality in the same time. And this is really a circular economy in practice when you run such a project. So thank you very much for listening.
I need to approach this. We do have some problems with the webinar. It should be automatically working, but we need to. So anyway, are there any questions from the audience on this presentation? Okay.
I have a question.
You have a question.
Did you follow me? Okay.
Yes, thumbs up. I have a question for you.
Yeah.
I was wondering, you've done these types of surveys for different sectors, I suppose. How long does it take to really dig into, for instance, Scania or Volvo?
We have learned the process now, so it's but you really have to. There is very often some things coming in between, etc. So from beginning of the project, it could take a long time. But actually, if you just run it, I think you could. I mean, you don't work 40 hours a week, but it might take 1 year to run such a project, because you should do those steps and learn the process. Very often you have the data already, so you could go back from. You don't have to collect data today. You could start with the data set you already have, but you will very often realize that you could see that the correlations are not 100%. There are things that are data that are missing, and then you sit down with RISE and the industry, with the process engineers and the quality department, and look deep into this. What are you actually missing? Which data are you not collecting today? And so this is a very interesting turn of the project.
Kind of an iterative
process.
Process.
Yeah, exactly.
Okay, but the companies that you've worked with, have they found their money value in this, or is it just? I shouldn't say just. I look at Tatjana for the environmental. I mean, the environmental concern is of course very important, but have they also saved money in these types of projects?
Yeah, they have. The force has most often been that they have a new permit ahead, so they have to reduce the water consumption. But then we have said that when you start to use separation technologies, you will have the process chemicals. So then we come in and try to tell them that maybe we'll not save money, but you will gain product quality, for example. And then they are interested.
That's quite interesting. Tatjana, wait.
もしもし。もしもし。
Thank you. Just a practical questions.
はいはい、とりあえずは。はい。
How do you see it actually? Do you do it on site, being connected to online sensors, or it's possible to do it offline somewhere else in Europe or in the world? Just in practical means, is it a specific program? Is it a specific system, people, or what is it?
Yeah, the question was, how do we run those projects? Do we have to be on site, or could you do it maybe in a laboratory or in another place? I should say that the data collection should be, we try always to work very applied. So we try to be on site because the processes are quite different at different sites, etc. And it's quite hard to simulate this in a smaller scale. So we try to collect data for the multi-rate analysis on site. But then I have to learn how to selectively take out the impurities by separation technologies. And then we often start at our laboratory in small pilot scale, bring 200 liters of water or 1 cubic meters of water. And then we do long-term tests on site in the end. So it's a combination of everything. And you could also run simulations, etc., in laboratory scale.
Okay, we actually have some questions from the net too.
Okay.
So, Helena.
Yes, the question is, how do they see the connection between energy and water in pulp and paper industry?
Maybe that's a question for Ignacio.
Okay. Yeah. No. So, how do they see, or how do we see? That will be probably the detail. So, water and energy, they go always together. In the sense of paper making requires energy. So every drop of water that we add to the system needs to be pumped and heated. Therefore, there will be always a connection. But many times, this energy cost, or compared to other energy costs in the factory, they are maybe not so important, not so heavy. However, if we consider the energy cost in the process, if we consider how much we lose on 1% efficiency, we consider how better we can do the production process, then is when we speak about big numbers. But again, it will be on this part that is indirectly related to the water usage. So the direct water usage, yes, you require some energy and will be a cost that should be identified and should be put in the same pocket, and therefore assign this cost to the water usage. I don't know, it would be good to know if I have answered the question, but they have to be optimized together in any case. Can I add, and maybe a comment, and it will be good to share. I think Staffan has put an important topic that we many times tend to forget. It's the cost of lack of stability, the cost of lack of quality, and how in many industrial processes we sell over quality because we are not able to control it. And therefore, I always put this example that for me, water is like the blood in a body. It has to move the good things to where they have to be and remove the bad things where they should not be. And therefore, is the key parameter for stability in a process. Somehow we know you have a break in the paper machine and then you lose 2 hours production until you are back again in production. What is the cost of these losses? And the other, and I think that's, so when you ask what is the benefit for Volvo in doing this? Okay, suddenly then you are in control. then you avoid selling always this maybe 1% additionally that you should not be selling, that it's lack of profit. So it's very, very important in that sense to keep the stability, and that a proper water management and a proper understanding of your process and what is really driving the quality. It's so important. And that's for paper industry, for car industry, or I would say for any kind of industry.
Okay, I like that. And I also remember one thing that you said in your presentation there, was that there's actually a combination here of experience and competence, or experience and knowledge, which is a kind of, interesting separation, I thought. So I'm looking forward to see more about this. Do we have more questions in the audience? In that case, yes.
Question, yes.
Okay.
I don't need the box. What was the reason why Volvo-Scania, for instance, were chosen to get your help? What was the main reason? Financial, or economic impact, or environmental impact, or?
Repeat the question.
Yeah, repeat the question. What was the driving force for Volvo and Scania and those companies to get into such projects? And I can't remember the start of the projects really, but I think maybe they from the beginning wanted some help with the separation technologies and so on, because we are experts in that. And then we said that maybe if you run such a project, you should also look into the possibility to not just recover water and reduce the water consumption. While you are doing those projects, why don't take control over your processes and do your product quality better? And we could run a little bit more extended project. And they thought it sounds good.
With that, I think we should thank our speakers, both of them, one more time. Thank you so much for coming. We have one more thing.